Hi all, in this lab, let us talk about re-platform using Amazon S3 and App Runner. In the earlier lab, we saw the typical monolith application where it is hosted on a VM on-prem, and we migrated that to the cloud using the rehost strategy, which is a lift and shift operation to the cloud, and we hosted the components in two EC2 machines. Now we will be re-platform one of the component which is front-end UI to S3 and one more component which is the app layer, which is a Java application to App Runner. Let's get started. So this is the current architecture that we had in the previous lab. So the application is now migrated to the cloud and it is being hosted on two EC2 machine and three typical application. So what we will be doing is we will be removing the app layer from EC2 and host that into a separate service called App Runner. App Runner is another service from the container services on AWS, which is used to host any web applications with a lot of abstraction already taken care. So, for example, App Runner will simply take the code base or the container repo image and build the entire pipeline and entire UI, auto scaling, and all of that, without really getting into the details from the end user perspective. So we will do a deep dive on App Runner later, but right now, assuming that we are using the App Runner to replace this application which is hosted on the EC2 machine. Then the App Runner will be talking to the backend database which is running on the EC2. So we have not yet refactored the database, it is still in the EC2. Now the UI, earlier it was on the Nginx which is running on the EC2. Now we will be migrating that to S3. S3 supports static web hosting. So the files for all the UI will be rendered from S3 bucket itself. So that means S3 will be talking to the app runner and app runner will be talking to the backend database. So that means the users will be now connecting to the S3 as a front end. And that means we don't need the EC2 machine running on the public subnet. So this is how we will be migrating one of the component to the S3 and one more component to the app runner as a part of the re-platform strategy. Let us now go to the source code and see how we are implementing this strategy in the code. This is the code base for implementing the Lab 2, which is basically a re-platform using the Amazon S3 and App Runner. Let's get started. So if you look at the source code, what we have done is we have Terraform files for the backend, App Runner, ECR, and S3. Okay. So first of all, we are copying the jar file from the S3 bucket into the current folder. Okay, so this jar file was already built in the previous lab 1 when we deploy EC2 machines. So this is the application layer which is currently running as a Spring Boot application. So this is copied to the container-app folder. So within this folder we have a Docker file. It is using Amazon Corretto JDK, which is the optimized runtime, JDK runtime from Amazon. And we are copying this file from local directory to this container folder. And from there, we'll be running this, a simple Docker file. And in the ecr.tf file, we are creating one ECR repo for this particular container image. And we are also building using the Docker provider. Okay, so this is the Docker underscore image resource, and this is where I'm providing the path for the the Docker file and the jar file. And then this is the platform I need to build for Linux slash AMD 64 because I'm running this on Mac system. So by default, Mac will be using the ARM64 architecture. So it's important to build it for the target architecture. Now I'm also using the docker underscore registry underscore image resource to upload this to ECR repo automatically. So instead of manually running the commands, I'm automating everything through the Terraform itself. So one path is basically moving to containers. Now instead of running the application inside a VM, now we are running this inside the container. Now to run the container, this is where we'll be creating a app runner service. So I'm using the app runner module, and this is my service name, and the service configuration looks like this. So it has to be deployed automatically, and the image is basically hosted in the ECR repo. This is the path for the repo, and the port is 8080 at which the service is exposed. And I also need to pass one of the environment variable for the mono to micro DB endpoint. So database is hosted in the EC2 machine, the EC2 machine private DNS name, which I have stored in the SSM parameter store in the previous lab. Okay, so I'm just retrieving that from the SSM parameter store into this variable. Next, I'm also configuring the authentication configuration. So access role is basically the IAM role which will be used by the app runner service to download the ECR image repo. Okay, because it has to access the ECR repository to download the images, right? So to pull the images, so that is the access permissions I need to provide. I can use a default role. It can also create a role, or I can provide my own role. Okay. And similarly, the health configuration, this is where my service is, servicing the health request, and this is my interval and timeout. By default, I'm providing one vCPU and 2 GB RAM for this instance. And there is instant role also. In case if this application needs to talk to any other AWS services, you can provide the corresponding IAM permissions through the instant role. So access role is for the app render service. The instant role is for the application to access the AWS resources. So you can also configure the networking, because this app runner service needs to talk to the the MySQL database which is running on the EC2. That means it has to connect to the EC2 machine through a VPC, because the EC2 is hosted in a private VPC. So that means how to create a VPC connector and put some name here, provide the list of subnets where the EC2 is hosted. So there's only one subnet, but I'm providing all the private subnets to connect, and security group with which the EC2 machine is currently configured. Okay, it's not the database security group, it is the EC2 machine where the Nginx and the app layer is created currently. Networking configuration, is it publicly accessible? Yes, we need to access this through internet, and the egress, the output from the app runner will go via VPC to the EC2 machine where the database is running. Okay, and observability you can enable. Then these are the access and the instant rule that we spoke about earlier. Okay, so these are all very subjective depending upon the application. Okay, now let us proceed further to understand how this is deploying the infrastructure for the second lab. Okay, so this is my ECR repo. This is the monolith is the name of the repo, and this is where the image is built and image is pushed from the Terraform. And this is what we'll be deploying in the app runner service. So in the app runner console, you can see that one of the service is deployed and it is successfully running. The name of the service is this, and this is the public facing endpoint to access the service. Okay. So let us look at the configuration for the service. So for example, the name of the service, the port, the one vCPU 2 GB RAM, the environment variable with the EC2 machine private DNS where the MySQL database is running. Then auto scaling, this is a default configuration. LCX we configured. Security, I just kept it default. And networking, this is where it's a public endpoint, but the egress traffic is through via VPC. Then these are the subnets where the database instances are part of, and this is security group which is currently configured, and observability is off. We can enable on, you can on or off, anything is fine for this demo. Okay, so let us open this URL and open this in a new tab, and you see the error message. So let us append this URL, one path unicorns. Okay. Now this is where you will see that the output is coming from the app runner. So this is basically app runner is now talking to the database and getting all the data from the database tables. Okay, so that means the app runner to database connection is working fine. Okay, now app runner is now properly working. Now let us go to the S3 bucket and configure the access to the app runner from S3. Okay, so before that, let's first go to the source code. This is where our UI code is running. So currently the Nginx is now talking to /API path. Now this API path will be talking to the backend application layer which is running on the EC2. So now I need to change this with the URL of the app runner. Okay, that means the Nginx is now um, talking to the app runner. When I say Nginx, it is a UI basically. Now the UI is now hosted in the S3 bucket. So let's go to the S3 bucket. So this is our S3 bucket. So one of the bucket is the UI bucket. Okay. So if I go to the UI bucket, you will see that the code for the UI is hosted here. And if I go to the properties, we can see that the web hosting is configured here. So this is the static web hosting enabled for this S3 bucket. So this is the URL. So if I just open this URL on a browser, you will see that the same UI what we saw earlier in the lab one is now appearing. Now if you see, this is coming from the S3 and we don't require Nginx or a separate EC2 machine to host to the Nginx and the application layer, which is a Java application. Now this is how we can re-platform the existing monolith into the cloud native architecture. So one of them is S3 for the UI using the static web hosting service, and also the app runner which is hosting the container image based the web service, right? The Java application running the container image. So this is how we can conclude that the two components from the monolith architectures are now migrated using the re-platform strategy to S3 and app runner.